Hi friends, welcome back. Today is lesson 93, going over comparative graphs. So this is playing off of what we've been doing with graphing. But before we go into that, we need to know what comparative graphs even means. So a comparative graph, I'm going to write that as a singular. A comparative graph is used to display two or more sets of data. Used to display two or more sets of data. So before I even start talking to you about what this means, we need to make sure that we are understanding graphs in general. So this is going to be very not realistic because I'm not taking the time to actually go through each piece of what different graphs are because we've been doing them. However, just a quick review. You should always, on your graph, this is going to be, it could be a bar graph or it can be a line graph. I was planning on doing a bar graph. Always has a title. Always. We cannot forget about that because it's telling us what data we're talking about. Otherwise, we really don't know. The same goes for down here. We have to label what is over here. Otherwise, again, it's like, what are you even talking about? So let's say that let's say we have a school play. And we have a school play that's set up for 3 nights, okay? And I'm gonna write nights. Let's say there's one on Friday night, Saturday, and Sunday. You can look at that and go, oh, okay, we're talking about Friday night, Saturday, Sunday night. Perfect. Then maybe over here, I want to know how many people attended each night. So attendance. Perfect. We can start with 0, but I would have to assume that more than one person came to attend this play. And I'm going to count by 50s. It's going to be the easiest increment for me to do. Instead of counting by like 2s or 5s, oh my gosh, that would be a humongous graph. You don't need to do that. You can do bigger increments if needed. I'll go to 250. Okay. Before I start graphing though, I still am missing a piece. That title, I have to write in that title. So on your paper, when dealing with the graph, sometimes when you have like a table of data that's telling you what numbers you're going to write down, typically it will already be titled. You can just copy that title right here. Because I'm just making this up, I'm going to say attendance at MLCA play. Ooh, okay, I fit it in there. So on the first night, Friday night, we had 100 people come. So we just line that up as best as we can. Okay. Saturday night, that's usually the busiest nights when we have plays. So let's say we had 225 people come. Well, there isn't a thing for 225, but we know that 25 comes in between 200 and 250, so we can just go right in the middle there. And then Sunday, most people had come to see the play by then, but there was still 100 people. So now when let's say I give you the graph to grade, or you made this graph up and I was grading it, I can see you have a title, so I know what pieces of data you're talking about. I have these axes labeled, so the x-axis, the y-axis. We have attendance, we have the nights. It's labeled with a nice increment. It's not counting by something too low, it's not counting by something too big. And then I'm labeled down here with the nights. If I didn't have a play on Thursday night, I do not need to write down Thursday. Same with Monday, Tuesday, Wednesday, whatever. I do not need to write in dates that aren't necessary unless we started with Monday. We can't skip Tuesday just to go to Wednesday. But in this case, we were going in the order that our days go, Friday, Saturday, Sunday. So we're good. This is a wonderful bar graph. And this is a vertical bar graph. So if we had a horizontal bar graph, we could really just flip this where the bars would be going, to the side. It's the same thing, but maybe our title would be in a different position, so it wouldn't be sideways. But the data is still the same, but it's just going an opposite direction. Horizontal bar graphs aren't used, in my knowledge, as much as vertical bar graphs are used, especially in the elementary age, but it's still important to know. So when you are going through your lessons and you see it says bar graph, you need to make sure that it's not specifying horizontal, because if it says horizontal, you need to make sure it's going left to right, not up and down. If it doesn't specify, if it just says draw a bar graph, it means a vertical bar graph. So I want to make sure that we are on the same page when it comes to bar graphs in general, because this point in your book, they're already assuming you know how to make one. They're assuming you know how to read one. And if I'm not making sure that you know that, then I'm setting you up for failure, and I do not want to do that. So before I go into comparative graphs, if you are someone who still is not understanding maybe how to set up a graph, how to read a graph like this, then you need to stop this video after my instructions. You need to go to iExcel. You need to type into the search bar after you have logged in, bar graphs. Don't pick something that, because they all are labeled, it could say bar graphs 8th grade. Don't do 8th grade. You can do 4th or 5th grade, and it will help you get those things in your brain. Remember, if you get one wrong, don't just click got it, because you're not reading why you got the problem wrong. Those things are there laid out to help you. Otherwise, if you still are wanting some extra help with it, or you just really still aren't getting it, watch a Khan Academy video. He is, like I have said in multiple videos before, he is phenomenal. I used to watch him when I was in high school to make sure that I was understanding the math I was being taught. Nobody is going to be upset at you for looking at other videos to help further your knowledge, okay? Just make sure mom and dad, grandma, grandpa, whoever know that you're doing that, so they don't think that you're messing around and not doing your homework. So, going into our comparative graph, I am going to show you the graph, because otherwise you're going to be so lost without seeing it. Otherwise, remember, you can look in your own book and follow along if it's easier to see. So we can automatically see on this graph. I want to make sure I'm not going to show you the answers. Nice. Okay. We can see that there are double graphs. Don't freak out. We're not there yet. We have to read the instructions first, and I will make sure to go through each piece with you. The average daily high temperatures in January and July for 5 cities is displayed in the comparative vertical bar graph below. So we can see that it's titled average daily high temperatures. Look at that, average daily high temperatures. They just took it. They have the temperature in Fahrenheit measured over here. They're counting by 20. And then they have the 5 cities labeled. It is important for us to look at this key. This is going to tell us, in Rome, in January, which is that lighter color blue, the temperature was about 50 degrees Fahrenheit, the high, which that's a pretty high temperature for winter. And then in July, in the summer, the average high temperature in Rome was about 90, because we're counting by 20s. So we have this for Venezuela, We have this for Australia, we have it for Paris, or France, excuse me, and then we have it for Japan. So there are a couple of ways that I taught the 5th graders last year how to do it. I don't care which way you use it. Just make sure that if you're going to follow the method of you writing in your book, you write it lightly, and then you always erase when you're done. It's not a time to doodle in your book, and you don't write super dark and hard, because then when you go to erase it, it's more likely to rip, and it's more likely to be stained in your book where someone else is going to read it and then just take the answers. So we don't want that to happen. We want them to do their own learning. So we already talked about how this Rome has an average high temperature of about 50 degrees Fahrenheit in January, and then an average high temperature of about 90 in July. We can do the same with each one of these as well, which is a really good idea, because then when you're going through these problems, all you have to do is look at the numbers. You're not going back and forth, back and forth, back and forth, because then it tends your memory and all the numbers start to get jumbled together, and then it could be more confusing and more stressful for you. So Venezuela, very hot. January's average temperature was about 70 degrees, where July didn't change too much, but let's just round it up to about 80. Sydney, Australia, in January, it was about 80 degrees. July was about 60 degrees. Paris, you can see it's about 40. And I don't know how easy it is for you to see these lines and how they match up with my book. So again, look in your book. It's going to help you see it better too. In July, it was about, I'm just kind of rounding to 80. We're not far off from 80, so it's just easier to deal with a whole number. Then Tokyo, about 50 degrees in January. And for this one, I'll say 85. Before we go on to these questions, when you are being asked to make a graph like this, do you see how January is always on the left, July is always on the right? And then obviously they're two different colors. You don't want to make like this January, this July, and then this July, this January. When you switch it up, it's way harder to read, and that's just not how a graph is supposed to be set up. It's supposed to ease all of the data that you're seeing, so when you do look at it, you're like, oh, that's pretty simple. I can just take out what I need. I can read this really quick. And all of this data that I've compiled, I've been recording for so long, is just here ready for me to read. So we don't want to confuse yourself, but when you're writing it down, drawing it, and you don't want to confuse the person that's reading it either. So we're now ready to answer A. In which city was the average July high temperature the highest? Well, since we have done all of the work already, we can just look at July. Okay, Rome was 90. Caracas, I think, is 80. Sydney is 60. Paris is 80. Tokyo is about 85. Well, the city that was the average highest in July, it's Rome. Sweet. Okay, A is done. B. In which city was the average January high temperature lowest? Okay, so smallest number. Well, January in Rome was 50. In Venezuela it was 70. Sydney it was 80. Paris it was 40. Tokyo is 50. Well, smallest out of those January temperatures is Paris with 40 degrees. C says, which city had the smallest range between these temperatures? Do you know why? Now, range. This is getting us back to previous lessons with like the mean, median, and mode. The range is the largest number subtracted by the smallest number. So, which city had the smallest range between these temperatures? Do you know why? So, it's having us look at each city. 90 minus 50 is 40. 80 minus 70 is 10. 80 minus 60 is 20. 80 minus 40 is 40. 85 minus 50 is 35. I can do math. It's 35. Which city had the smallest range between these temperatures? Well, the one that was the smallest when we subtracted was Venezuela, but I'm going to just write the city down because that's what it's asking, which city. Do you know why? This is a question that, adults can't answer, so it would kind of be a bonus question, really. So, in case you wanted to know or you didn't know, this city in Venezuela is located near the equator, so the temperatures near the equator don't vary through the year as much as somewhere like us. We're far from the equator. We have really, really hot summers and we have really, really cold winters. Whereas Venezuela, where the city is, it doesn't vary up and down as much. So it was just a 10-degree difference. So they're warm most of the year. D. For which city is the average January high temperature greater than the average July high temperature? Do you know why? Okay, so I'm going to read it one more time. For which city is the average January high temperature, okay, so light blue, greater than the average July high temperature? Well, this is really just saying we want to look for a light blue bar that's taller than a dark blue bar. So is this light blue bar taller than this one? No. Is this light one taller than this one? No. Is this one taller than this one? Yes, but we'll come back just in case. Is this taller than this? No. Is this taller than this? Boom. Sydney. Sydney, Australia. I can't talk with an Australian accent. Do you know why? Some of you might know. So, just to inform you again, Australia is warmer in January than in July because it's south of the equator. So, when you're south of the equator, January is summertime, July is wintertime. So, complete opposite of us. Obviously, we know in Moses Lake, January is winter, July is summer. So when we're celebrating summer vacation and being warm, the Australians are getting a little bit colder. They might be in school again. They might be getting, doing some sort of different activities than we are because their climate is different than ours. So remember, if you marked in your book with me, just erase it. You don't have to do it right this second, just in case you need to reference back, but please don't forget. So if you need to fold down the page or put a pencil there or something, do that so you don't forget to come back to it. Okay. The other one that it's having us practice has to do with a line graph. So as a review of a line graph quickly, we still need a title, always, no matter what kind of graph you have. You always need to label the X and the Y axis. And then instead of being labeled with a bar, it's labeled with dots. I'm sorry. You know what? I won't be lazy. I'm just going to copy this information that's down here. So nights. Attendance. And then I'm just gonna abbreviate this, MLCA play. Don't do this don't cut corners while you're labeling your graph. I'm only doing it so you're not just sitting here watching me put together a graph that you've already seen from up here. The reason I'm redoing it is just so you can see the difference in data collection. So it didn't change from up here. Friday was still 100 people that came, but where you designate it with a dot. Saturday night, 225 people came. And then on Sunday night, 100 people came again. Now, all we do like you do when you're in kindergarten and first grade. I personally love it, connecting the dots. So this is showing us different data. You see this a lot on TV or in books like medical journals or scientific journals of sorts, and it's showing like a big either increase in something or a big decrease in something. If you've been watching the news at all with your parents, or you just kind of see it as you're walking through, you might see that they're doing this for COVID. There's, maybe a big increase in people who have it, and then all of a sudden, whoo, big decrease, which is such a blessing. But it's showing how maybe this many people had it one day, and then all of a sudden we had this many people who had it the next day, something like that. So hopefully a line graph makes sense. If it should just be a review. But again, if you are still struggling with it, go to IXL just like I had you do for the bar graph. You can practice, I'm pretty sure, every single kind of graph or data table that the Saxon book has you do. You can do it on IXL. Sorry, I'm getting ahead of myself. I gotta hold my phone. I'm sorry if it's a little shaky. I naturally shake a little bit. We can use a double line graph to show how two or more things change in relation to one another. For example, the double line graph below shows the change in population of the cities of Austin and Pittsburgh from 1950 to 2000. The legend to the right tells which line belongs to which city. So you can see that the solid line with solid circles is Austin, Texas, okay? And then this solid line with not filled in circles is Pittsburgh. So which one had an increase? This is not a question. I just want you to be able to see if you can figure it out. Which city had an increased population from 1950 to 2000? Well, looking at this legend or the key, that's another fancy word. It's Austin. Austin had an increase in population from 1950. You can see it went up over time. Pittsburgh, however, went from being a super large city, super large, down. It's still a significantly large city, but it went down in population. So it says approximately what was Austin's population in 1970? So looking at our key or our legend, we know that it's the solid line with filled in circles. We look at the year 1970, and it's in between 200 and 300,000 people. So you can make the determination that approximately 250,000 people, okay? It says approximately what was the population, so you could probably just put 250,000. I'd prefer if you put 250,000 people, okay, because it could be dogs and cats and fish and horses and donkeys, but we want to make sure that we're specifically talking about people. B, approximately how much did Pittsburgh's population decrease between 1950 and 2000? You guys weren't even born yet. So we started at 700,000 people, and we went down to about 350. You have to do the math. 700,000 minus 350,000 is 350,000. People. So remember, like I was just saying, this is a really good data collector to show an increase or a decrease in something. It could be the amount of pizza that was eaten at school. Maybe the time that you were in kindergarten to the time that you were in 5th grade. Each year, let's say that we ate more pizza every Wednesday on chapel days. Or it's the amount of people who go to Silverwood in the summer. Maybe June of last year was the most people they've ever had for one summer, whereas this year it might be dramatically lower because we might not have as many people going because of people being sick. It's a really, really good way to show this data. So I'm going to just show you really quick. On your lesson practice, I don't want to show you the answer. The lesson practice that I've been talking about in your book, there is this one that's talking about a horizontal bar graph. It explicitly states if it's horizontal or vertical. You are looking at the table, and then you are labeling that data graph, this bar graph. So a horizontal bar graph, it's the same thing that we talked about with a vertical bar graph, except it's just flipped on its side. So I'll show you the answer here in a second so you can just see what I mean. But Shannara, maybe? Alice, Terrell, and Manuel each wrote 2 stories. The number of paragraphs per story is shown in the table below. So Shannara, her first story had 8 paragraphs, her second story had 8 paragraphs. Alice's first story had 3, her second had 6. Terrell had 6 paragraphs in the first story, 7 in the second story. Manuel had a lot of information. He did 7 paragraphs in the first story, 10 in the second story. Make a comparative horizontal bar graph to show the scores. There should be 2 bars for each student because we are showing for story 1 and story 2. So I'm going to flip my camera here. So you can see that there are 2 little bars for each student. And this is shown by like dots or lines or something. When you are asked to make a graph like this, use different colors. It's the easiest thing to do if for some reason you don't have access to colors. Even if it's blue and black or red and blue, red and black, whatever it is. If you don't have access to colors, then do something as simple as polka dots and stripes. Or blank, like having just a blank bar, like this would be a blank bar, and then your next one would be polka dots. We want to do something simple that's easy to read. You can see that the names of the people are on this axis here. So we can read it going this way, right? The numbers are at the bottom. So if it was a vertical bar graph, just pretend that the numbers here, the numbers would be on this side. The people would still be right here, but their names could be turned so it'd be easier to read. But for this case, it's having you look at a horizontal bar graph. So hopefully, you have a really good understanding of what a bar graph is, horizontal and vertical, and what a line graph is. When you are doing your lesson, I'm looking right now at what your lesson is asking you to do for this lesson. I honestly do not see one. I don't know if it's actually having you make a graph today for your lesson. Nope. So it will come in further lessons, so we don't want to just forget about this information. I wouldn't have just taught you something just to teach you. I don't want to waste your time. So again, I know I say this every video, you're probably tired of it, but if you need help, if you need extra assistance, if something's still not making sense, you want extra practice problems, you can call me, you can text me, you can email me. I would love to Zoom call. It's the easiest way to do it, so then that way I can show you what I'm doing on a piece of paper while we're talking together instead of just being on the phone where we're just hearing each other. But don't be afraid to ask for help. Remember, if your parents are helping you with this kind of stuff, I'm sure they are. Your parents are awesome. They're phenomenal. Don't get mad at them if they are doing something that's different than me or if they aren't understanding either. They have a lot of things that they're doing right now. You have a lot of things that you're doing right now. You just need to be patient. They need to be patient with you. And we're going to get through this, guys. You're doing really, really, really awesome things, and you're going to continue doing awesome things. So I'm really proud of you. This is a lot of information. I think this is the longest video we've done yet. So if you've stuck around this long, awesome. And I hope to see you soon. Have a great weekend. Love you all.